Okay, so our next big chapter in this course is mixed programming with Python. So we've learned pure Python, we learned NumPy, and now we'll show you how you can actually mix different languages and call external programs with Python, or external libraries with Python. So I will show you, after some introduction, I will give you an overview of different tools that you can use, and I will also point you to a code repository where I've collected minimal examples on how you interface a C or C++ program with all these different tools. So is Python slow for numerical computing? So imagine again we have the same task as we had previously. We want to create a NumPy array and we want to fill it with function values. A Python implementation is exactly what we had before, right? Our loop written out explicitly. We will figure out that this is not the fastest way of doing it. And if we actually time now different implementations and we normalize it, so I have a Fortran implementation, I have a NumPy vectorized evaluation, which I've shown you just now. I have a Python loop version where I use math.sign, and I have a Python loop version where I use numpy.sign. And these timings here on the right-hand side are now normalized. And you can see that the Fortran and the C and C++ implementations are by far the fastest. The next thing is NumPy vectorized evaluation. It's 3 times slower than the pure C, C++, which is quite impressive, I think. But then when we move on to the loop versions, right, we get 140 times slower or 350 times slower than the C and C++ versions. So now if we're talking about a time-critical application, right, then this is quite significant. And so what is our strategy here? So Python loops over arrays, we know now they're extremely slow. And so the first thing that we should do is we could vectorize our program using NumPy arrays, and that might actually be sufficient, right? But sometimes you can't vectorize, or maybe it's sometimes not convenient to vectorize, and then it might actually be a lot easier to just write out the loop in normal C, C++, or Fortran. And so why is it that these compiled languages are so much faster? And the thing is that we have the compilation step. That's really the big difference, right? In all these languages, we compile, while in Python, we only have an interpreter. And these compilers, they're really good at optimizing your code and at optimizing loops and these things. They can figure out how you can rearrange the program to make it run faster. And so just some examples here is code inlining, loop unrolling, and memory prefetching. So these are all techniques that the compiler uses to speed up your program. So it inspects the program and then rearranges it. On contrast, in Python, we don't have a compiler, right? We also don't have types for our variables. So the program always needs to basically check which types we are getting in because we can't infer it in advance. We can also do no inlining and no loop unrolling. So inlining basically means that if you call a function, if you have a function call, and then instead of calling the function, you just copy the code of that function inside the main code. So you don't actually have to call the function because you just copied the content of that function, right? So all these techniques that you can't really do in Python. And so which means that something simple like this, where you just you define a function f with a and b and you return a plus b, this is a lot of overhead is going on here. So when you call this function, it needs to check the types of a and b, then it needs to add them up and do some conversions for the return statement and so on and so forth. So ideally what we want, right, we want to, at least in some cases, we would like to combine a compiled language and a Python language. And so here's an overview of different mixed programming tools that you could use for this. So they're basically, you can categorize them in 2 different ways. One is extending Python versus embedding Python. So when you extend Pythons, when we talk about extending Python, then we want to, in our Python program, we want to call external libraries or functions written in other languages, for example, C and C++. Another technique could be to embed Python. So in this works the other way around. So we have maybe a C++ function and a C++ program, and then in that C++ program, we could launch out to a Python interpreter, do some Python computations, and then jump back to the C++ function. Right, so in this case, we would embed Python in an existing existing program. So in this course, I will only talk about extending Python. Okay, so we're not going to talk about embedding. And so there are two main use cases that we will cover. The first one is that we would like to access functions that already exist or that have been implemented in other C and C++ functions. So we don't want to reinvent existing tools. And the second one is that we want to speed up our Python program by migrating slow loops to C and C++. Right? This would be the previous slides demonstrate an example of this. So here's a summary of tools that you could use. So this is just to give you an overview. I will tell you much more about a specific tool, Python, in a second. So the most low-level way that you could use is to handwrite the wrapper code between Python and C. So Python is written in C, and so there's this Python C API that you can use to actually call C programs or C functions from Python. So this approach is very general. You have a lot of control. There's no need for additional libraries and tools. But the disadvantage is that it's extremely time-consuming, and you have quite a lot of overhead, that implementation overhead and code overhead. Then there's C types. So C types is also part of the standard library, and yeah, it's a way for you to it allows you to convert C data types to Python data types. And again, there's no compiling step, and all wrapper code can be written in Python. But again, it has some disadvantages. It doesn't really support C++, and all these wrapper code introduces a lot of overhead that you need to take care of. Then we have Swig. So the idea of Swig is to, given a C or C++ library, how can I make a Python interface to it? Okay? And so the way it works is that it actually auto-generates a lot of the wrapper code that we had to do before by hand, and it works with C++ and supports actually not just Python, but also other programming languages. But we still have to write some, so the automated wrapper code is quite large and hard to debug, so this is a disadvantage. And we also have to write some interface code, which is often not so easy. Then there's Instant. So Instant is a tool where you can just write C code as a string in your Python program, and then automatically compile it and make a module. And Instant will automatically compile it and make a module out of it that you can load. So it's really easy to use for the purposes which it was intended for, but as a general purpose wrapper tool, so if you leave the scope for what it was designed, then it becomes inconvenient. And finally, we have Python. So Python is an approach that extends the Python language with elements of C. And so with a Python program, we actually need to compile it. But once we've compiled it, it becomes a normal Python module that we can load in. And so Python has become quite large, and there's quite a bit of users and developers that use it. And there's actually quite a lot of possibilities and advanced tools that you can use. So the advantage here is that you get the flexibility of Python with the speed of C, but the disadvantage is, in particular for bigger programs, the code can be quite complicated, and we're actually not working with Python nor with C. We're kind of working with something in between. You'll see this in a second. So these are a lot of tools, and so you have to kind of figure out which tool you want to use for a specific purpose. And quite often it's a bit difficult to get started with these tools, so I created a code repository that contains examples for how to use these tools just on a very simple problem. And so here's where you can download these code snippets, and there's a folder called Mixed. And in there I have a demo where you can see how you can use instant with. So one problem is always so typically just using these tools with normal Python is relatively straightforward, but then you often want to use NumPy, right? And so I here have examples where I use instant with NumPy and also with two-dimensional NumPy arrays. I have an example with Swig with and without NumPy arrays, and I also created a Python example with and without NumPy arrays. So in particular, if you're not entirely sure, you want to have a starting point that you know works.